So starting out, we have the Pythagorean theorem. Does anybody remember what the Pythagorean theorem is? Good. A squared plus b squared equals c squared. All right.
D squared.
What did you say?
All over d squared.
All over d squared, yeah. 2d squared. No, just kidding. Okay, so that's the normal Pythagorean theorem, okay? And up here, too, is the converse, which basically just says if you can prove that c squared is equal to a squared plus b squared, you can say that whatever triangle you're trying to look at is a right triangle. Okay, so you might want to highlight that because, hint, hint, it's kind of important for some of the stuff that you're going to be doing today. Hint, hint. Okay, so if you can prove that that holds true, you can say that it is a right triangle. Okay. Has anybody heard of a Pythagorean triple before? Ooh, what is it? Anybody know? You just heard the name? Yeah, you're right. They are common triangle side lengths. Does anybody know what makes them special? There's something kind of like cool about them, I guess. If you think it's cool, I mean it's kind of cool. So the cool thing about them is basically that if you notice, they're all like pretty perfect whole numbers. So 3, 4, 5 is still a right triangle. 5, 12, 13 is a right triangle. But notice they're all like perfect whole numbers. Okay? So in part of the homework today, you will be asked if something is a Pythagorean triple. So the way to kind of figure that out is just to know kind of these basic ones and be able to tell if it's a multiple of them. So that's what that means down at the bottom there, that 3x, 4x, and 5x. Any multiple of the Pythagorean triple is still a Pythagorean triple. Okay? All right. All right. So triangle inequalities theorem. So this says the sum of the lengths of any two sides is greater than the third side. So something to really kind of keep in mind here. If I have a triangle, okay, if I have a triangle, make sure that when you're checking this, you're checking the side lengths themselves. So don't square it before you check it. Okay, so it is saying that A plus B is bigger than C, or B plus C is bigger than A. So not the squared of each of them, okay? You might want to make a note of that. That tripped some people up yesterday. So it's the actual side lengths, not the square of the side lengths. Okay?
You'll be asked two different things, guys. Sometimes you'll be asked, could these three ABC values be a triangle? That's when you're checking it without squaring. Sometimes it'll ask you to classify the triangle. So it'll tell you it's a triangle already. It'll ask you to classify it. Those are the inequalities she's about to get into. Okay? So classifying a triangle is when you're actually going to square them. If you're just trying to prove if it could be a triangle or not, that's when you're not squaring. Okay, so you got to be careful with those two questions because they're similar.
They're super similar. Okay, so like we already said, if we have a right triangle, then we know that a squared plus b squared is equal to c squared. So this would be a right triangle. Okay, notice over here it says that if c squared is less than a squared plus b squared, the triangle is what? Good, acute. And if c squared is bigger than the two side lengths put together, the triangle is obtuse. Okay? So that's kind of how you tell the difference.
Obtuse. That was the first.
She goes, oh, okay. She's not going to argue with you. Mm-hmm. All right. How does everybody kind of feel about this first page? Just kind of the boring definition concept stuff. I mean, super fun concept stuff. I know it's not that great. All right, what do we think? Good? Okay. All right, so this is kind of what Mr. Craw was talking about. It wants to know if the sides form a Pythagorean triple. So what does it need to form? Hi. Thank you. What does it need to form if it is a Pythagorean triple? What do all the side lengths need to be?
Whole numbers.
Good, pretty perfect whole numbers, okay? So, how would we calculate that last side?
64 plus 49 squared.
Good, so 8 squared plus 7 squared equals c squared.
It's not a whole number.
It's not. What is the radical on that one? When you actually do that? Anybody put it in your calculator? What'd you get?
Square root of 113.
Square root of 113.
What?
Okay, so because the square root of 113 isn't a pretty perfect whole number, you would say no. Okay. All right, let's move down to 3. Find the length of the missing side. Okay, so this one's pretty easy. How do you know which one is the hypotenuse? So if you're given a picture like that, how do you know which one's the hypotenuse? Yeah.
It's the side opposite of the right angle.
Good, it's always the side opposite the right angle. Okay? So for this one, we would get 4 squared is equal to radical 7 squared plus b squared. Whoa, that was bad. Okay, so we'd get 16 is equal to 7 plus b, right? So b is equal to what? Sorry, b squared is equal to what? 16 minus 7, don't hurt yourself. What is it? 9. Okay, so b would be 3. Okay, so that'd be the missing side. Is this a Pythagorean triple? Doesn't ask this, but I'm just asking. No, why not? Good, I've got that radical 7. All right, so go ahead and try 2 and 4 on your own. 2 and 4.
Bunch of slightly adjust, slightly adjust, slightly adjust. It's going to get your answer pretty off towards the end. It's okay to approximate when you're trying to prove if it's a triangle or not. But when you're doing Pythagorean theorem, make sure that you're using the exact radical. Okay.
So if I did 5 squared, I would get 25. And then so if I did radical 56 squared, those would just kind of cancel out, and I would get my plus 56. All right. So what is 25 plus 56? Good, 81. So notice that 81 is equal to 81, which means what? Is it obtuse, acute, or right? Right. So it is indeed a right triangle. All right. All right, go ahead and try the rest of just this page.